Sasrikal students, let's discuss bending of a cyclist. Well, this is the tire of the cyclist. This is a cycle. This horizontal line can be considered as the handle of the cycle. And let's say this is the center of gravity of the cycle, this point. Okay. Now, uh, this point, a lot of forces are acting, and this horizontal line can be considered as handle of cycle, or it can be considered simply a line which is parallel to the handle of the cycle, which might be here also. Since this is the center of gravity, so handle might be here. Okay, so it doesn't matter. So this point is the center of gravity. On this point, the weight of the cycle obviously will always act downwards, mg, right? M is the mass of the cyclist along with the cycle. V is the velocity while turning. R is the radius of circular path. This R is the radius of circular path. I mean, this is a circular path. Draw this complete circle. Then this will be the radius. Theta is the angle of bending. Now we want to find out at what angle the cyclist should bend, right? So that with V velocity, he can, you know, easily take the turn at v velocity. Okay. Interestingly, students, when the theta will be more, you will see the permissible velocity at which he can take a turn can be increased, right? So that is the reason, students, you must have seen that the motorcyclists, while taking a steep turn, they almost touch their knee to the ground, almost touch their knee to the ground. They bend so much, they bend very far, they bend so steep, so that they can take the turn at a higher velocity. More is the theta, more can be the velocity with which the turning can be taken. Turn can be taken. Theta is not applicable when it is a straight road. So students, now we will see the free body diagram here. And now R is in this direction. You might wonder why, because R normal reaction is always perpendicular to the plane. So this is the plane, right? Or this is the plane of the cycle now. So R is at this angle, right? R can be resolved in two components, R cos theta. Been always telling you the component of a vector which is touching the theta is always cos theta, right students? So it's r cos theta, and then we can write the opposite to theta. This is opposite to theta, this component in right direction. This is r sine theta. So very simple, students. If the vector is in this direction, we want to take its component. So one component will be left, right to left, and other component you can just consider like this. Point A is moving to point B. It has moved upwards. At the same time, point A has moved left side. So you will never draw the component of AB as in this direction. Rather, you will draw it in right to left direction, then bottom to up direction, right? Suppose it's like this. You want to resolve this into components. So first component will be left to right, and second component will be up to down, right? This is a basic way you can resolve into components. Common sense will help you. So r can be resolved into r cos theta and r sin theta. R sin theta is basically, balancing the centrifugal force acting on the cycle as well as the cyclist both, right? mv square by r is a centrifugal force acting outwards. So this centrifugal force will be balanced by r sine theta. Now students, you see the value of theta increases, the value of sine theta also increases. From trigonometry, we know that the value of sine 0 is 0, and the value of sine pi by 2 is 1. So that means as the theta is increasing, the value of sine theta is also increasing. From this very good judgment we can take that when theta is increasing, see, when theta is increasing, r sine theta will also increase. When r sine theta will increase, that means it will be able to balance more centrifugal force. You know, that means when r sine theta is increasing, then even when v is increasing, it can balance mv square by r at higher velocities. Am I right? So when velocity is less, the value of mv square by r will be less. Then even theta can be less. That means a cyclist doesn't have to bend more. It can bend little bit, which will balance the mv square. One question is, what does r sine theta is doing? Ishma, can you answer? Or in other words, why the bending is done? Why the cyclist bend? Or in other words, what does r sine theta do? Can you answer? Or you can answer?
It is balancing the centripetal force.
It is balancing, Ishma, centrifugal force. Centripetal force is acting in the direction of r sine theta towards the center. It is balancing the centrifugal force, which is trying to, you know, trying to throw the cyclist along with his cycle away from the track, right? We have to bend to compensate for the mv square by r, that is centrifugal force. You might be wondering why I am saying mv square by r. Actually, I am applying Newton's third law. Mv square by r is an expression for centripetal force, but centripetal force is equal to centrifugal force. So I say centrifugal force is mv square by r. So very well said. R sine theta is basically balancing centrifugal force, which is acting outwards from the track. If I take a turn like this, then centrifugal force will be in this way, right? Okay. So having understood all this, now students, what I will write the equations. So R cos theta, component of normal reaction in upward direction, is balancing what? The weight of the cycle mg is my first equation. Then r sine theta, the component of normal reaction acting towards the center, is balancing centrifugal force, exactly acting in the opposite direction. So students, very simple. Now what I can do, I can simply divide, let's say this equation is 2, I can simply divide 2 equation by equation 1. So it will be r sine theta divided by r cos theta would be equal to, will be, yeah, this will be, not r will cancel with r, it will become only tan theta. So it will be equal to, Ishma, please speak, mv square by r, please speak, divided by mg. Good. M will cancel with m, so what we will get, this is equal to v square by rg, not g, rg. So r will cancel with r, so very simple, I will get tan theta is equal to v square by rg. Am I right? So from this, students, I will get, what is the value for theta? Theta will be equal to tan inverse v square by rg. Very simple, I will get the angle of the bending, right? So if v is given, right, what is v? The velocity of the cyclist while turning. And if suppose the radius of radius is given, right? So we can say we will be able to find theta. From this, students, we can make a very interesting uh, judgment. Can you tell, Ishma, that you see, if r is more, if radius of track is more, means r is like this r is more.
Theta will be less.
Beautiful. When r is more, theta will be less. What does that mean? If I am going uh, on a track where it is more radius, then I need not bend much, right, Ishma? But if I'm taking a steep turn, the velocity is same, let's say, then if I'm taking a steep turn means very quick turn. See, this is a still quicker turn. Here radius will be more is a steep turn, lesser will be the radius, and if more is the radius, the turning is very less, right? When the turning is very quick, then what? The theta r will be less. When r will be less, theta will be more. Theta will be more means this cyclist, suppose is like this, it has to bend more, this theta will be more. If it is still more velocity, theta will be more. So students, this is very important. Now there can be, there is a question also like this, that prove that at higher velocities, the theta or the cyclist should bend more. So from this you can easily prove that v is directly proportional to tan theta, or theta is proportional to tan theta, because as the theta is increasing, the value of tan theta is also increasing. Students, do you know the value of tan theta at 0? What is tan 0? Tan 0 is sin 0 by cos 0, that is equal to 0. And tan infinite, pi by 2 is infinity. So tan theta is increasing from 0 to 90 degree. Hence, this is the uh, derivation of the formula. Whether somebody asks you velocity or whether somebody asks you theta, you can both find by this velocity. Okay. So now we will do a small numerical on this. It says aircraft executes a horizontal loop. Aircraft executes a horizontal loop at a speed of 720 kilometer per hour with its wings banked at 15 degree. The wings are banked at 15 degree. Okay. What is the radius of the loop? What is the radius of the loop? So very simple. We will apply the same formula, but tan theta is equal to v square by r g. Am I right? Here theta is 15 degree. Okay. And v is 720. We can easily convert it to meter per second by simply multiplying by 5 by 18. Always remember. So 18 4 is 40. So this will be Panchuki v 200 meter per second. This is the velocity. This is the velocity. Now we will see that what will be r. It's very simple. R will be equal to v square divided by r into tan theta. Am I right? R is equal to v square divided by g into tan theta. So this is equal to what is v? 200 square. So it will be 200 into 200 divided by what is g. Let's say, let's take it as 10 into tan theta into tan 15. This value we can find. So r is equal to 1.52 into 10 raised to power 4 meter. So student, this will be the radius. Thank you very much. Wish you all the best. Subscribe our channel Learn CBSE. This is the complete name of our channel to see more videos. All right. Wish you all the best.